Hello everyone. So far we have studied why transducer effect is needed in sensors. We briefly discussed that almost all the sensors have a transducer effect associated with it, especially because you want to convert one energy to another energy. For example, if you have a sensor and you have certain sort of energy E1, maybe if you consider the example of a temperature sensor, then E1 is heat energy, right? And then if your sensor is electronic sensor, you need to convert this energy to electrical energy, so which is E2. Now conversion from one energy to another energy is what is known as transducer effect. So almost all the sensors, not all sensors need a transducer effect, but almost all the sensors have a transducer effect, and we have discussed this in our previous lecture. We also have discussed why sensor is needed. So this like sensor. So sensor is required for many of the smart applications. If you take smart devices, in almost all the smart devices, you'll find that there are at least multiple sensors integrated to it, because when a device is smart, it needs to give you certain sort of indication or output based on its surroundings. And how they get this type of information? I mean, that information they get from different kind of sensors associated with them. Okay, that's why. And we also have to some extent discussed other reasons why sensors are needed. We also have discussed types of measurements so far. What are the different types of measurements associated with sensor? Then we have seen the classifications of sensor, how and on what basis we can classify or segregate different types of sensors that we have seen. Now today we will discuss about materials, which is again a very important aspect of sensors, because almost, or in fact all the sensors are made of certain sort of material. What are those materials? Why do we need different types of materials? We will briefly discuss what are the material aspect of sensors. We will not go deep into the materials, but it's very important that as a sensor engineer you know that what are the different types of materials that can be used for certain sensor fabrication. As we know that sensor has majorly two different components. One is the substrate. Substrate is where you make the sensor. If you have a temperature sensor, you need a substrate on which you will make the sensor. Then you have active materials. Active materials meaning the material that is responsible for sensing operation. For example, if it is a temperature sensor, you need a material which is temperature responsive. You need a material that will respond to temperature in different ways. Otherwise, it's very difficult to detect temperature. So in that aspect, you will find there are different substrate materials based on the application, and we also choose different active materials for same sensing application. In fact, this itself is an area of research, whether we can make or get certain sort of materials that may provide you higher sensitivity, higher range, and so on and so forth, right? Apart from that, there are different other components associated with sensors that require material consideration. One is the electrodes, right? Because when you make a sensor, it can be 2 electrode system, it can be 3 electrode system, it can be multiple electrode system as well. So it's very important that you choose a material which is suitable for that particular sensor application. For wire bonding also you need some material, because once you have a sensor, for example, say this is electrode in 2 sides, then you need to connect this with system for operation, and for that purpose you need wire bonding. Mostly it's wire bonding, sometimes you also solder it. There are different ways of connecting it, but this is one of the processes, right? Then for packaging also you need material, because once you make the device, that device has to be encapsulated with a packaging material. In most of the cases when you see an IC, all ICs look same because they are packaged in that way. So all are mostly covered with a black material. So this is the packaging material. So you need to choose a packaging material based on the sensor. For example, if you are working with a temperature sensor, you should make sure that the packaging material can conduct heat and the heat energy should come in contact with the sensor. Otherwise, the sensor cannot measure the temperature. For example, if this is your this one is your temperature sensor, then you package it with a material. Say this is the packaging material. This should conduct the heat from outside to the active material. If it's a thermal insulator, then it's difficult for this sensor to detect temperature outside, because anyways this heat energy will not get transferred to the active material. So you need to choose a material, suitable material for packaging as well. Then insulation. So sometimes we also need insulation. So what is insulation? Insulation is, for example, if you have a sensor, so this is your sensor, it's a top view of a sensor. You have a active material here, and then you create electrode. For example, say this is the electrode. Now, if this sensor is used to detect certain chemical, you dip or you drop a chemical on top of the sensor, or you may dip this sensor inside a liquid. So when this chemical comes in contact with this active material, it generates an output, and that output is what is your calibration curve. From there you can detect what is the concentration of that chemical in that particular solution. Now oftentimes you may find that the chemical that you are detecting is actually not good for the electrode material. It corrodes the electrode material. So to protect the electrode from that chemical, what you do is you put an extra layer on top of the electrode, which is known as insulation. Okay, and then you take out some wire bonded things from there. This is just to make sure that your electrode is protected. So we made a sensor where the active material is only exposed to the chemical under concentration. Electrode is insulated from rest of the part. Okay, so this is what insulation is all about. So for insulation also we need different types of materials. Okay, so these are different components that need a kind of a material consideration. So let us go to those aspects one after another. So let's discuss first the substrate material. Now, broadly speaking, the substrate material can be divided into two different parts. One is rigid substrate, where your substrate is very rigid, that is you can't bend it, it's very firm and rigid. And the other one is flexible substrate. This substrate, flexible substrate, is used mostly for wearable devices, where your substrate is kind of bendable, stretchable, and so on and so forth, right? Now, apart from that, you may need substrates which probably is opaque, transparent, maybe disposable or wearable. So these are different other aspects of substrates. For example, if you are making an optical sensor, and for example, say here I have taken a substrate, on top of that there will be an optical sensor, right? And you are going to place the entire sensor, say upside down, or your optical signal will come from the bottom. In that case, your substrate has to be transparent, because this optical signal has to reach to the active material. Until and unless the optical signal is interacting with the active material, you will not get any sort of response. That's why you need a transparent substrate. That transparent substrate can be rigid, can be flexible. Okay. So these are different sub part of the substrate consideration. In broader aspect, you either need a rigid substrate or a flexible substrate for making a sensor. Now, two different very well kind of utilized substrate, or I would say popular substrates are glass and silicon. Both these substrates are widely used as a rigid substrate. You may also find, say, FR4. This is again not for a sensor specifically, but for circuits. You'll find that FR4 is a very good substrate for making PCBs, and so on and so forth. You may find different other examples as well, but I am giving the popular examples over here. So glass and silicon are two different substrates that are used for sensor fabrication as far as the rigid aspect is concerned. Now, in flexible, you will find different polymers are used. PDMS is a kind of polymer which is a transparent polymer and is widely used in different sensor fabrication. So I am not going in details of these polymers. You can very quickly go to the internet and search what is the full form of PDMS, what is the full form of PVC. So I am not going in that details, because the purpose of this particular lecture is to give you an idea about what are different material considerations and some examples of different materials. So a PDMS is a kind of PVC is a kind of well-known acronym in this regard. We also take polyimide as a flexible substrate. Polyimide is kind of heat resistant. So for different high temperature applications, if it's flexible sensor is needed, usually people prefer polyimide. Then there is another material called EcoFlex, which is also stretchable. So these are different flexible substrates that you may find that people are using for different sensor fabrication. So you have rigid substrate, you have flexible substrate. Then if you need a flexible transparent substrate, you may use PDMS. If you need a transparent rigid substrate, then you have glass substrate. Okay, and then based on your application, you can choose these substrates. It's up to the sensor designer. Okay, that what substrate you want to choose for certain application. Then let us discuss about active material. Okay, so usually active materials are chosen based on the electrical properties. So the active material can be conducting, this can be semiconducting, this also can be insulating. Based on the kind of application you are using these active materials in, right? So some of the examples I have given, for example, if the active material is conducting, then definitely the material will be carbon based, or say metal. Metal is maybe one of the popular choice in conducting materials. Then you may also use some sort of polymers. These are also conducting. For example, some conducting polymers are already available commercially. You can use those polymers, or you can synthesize a conducting polymer for certain sensor fabrication. Then we also use semiconducting active materials. In that case, you can use metal oxides, nitrides, maybe sulfides also for semiconducting application. There are different semiconducting polymers also that you may consider for developing a sensor. And then you may need insulators, especially for, say, if it's a FET based device, then for the gate dielectrics you need an insulating material. Sometimes I mean, in most of the cases your substrate material is kind of insulating. So there are plenty of insulating materials available. Different polymers are insulating. For example, the polymers that I have mentioned over here all are insulating, right? So, and then there are oxides that are also kind of insulating, for example, silicon oxide. So you can use one of these materials as a insulator. Then apart from that, you also can select an active material based on their physical property or mechanical property. For example, you need a flexible active material. For example, you need a stretchable active material. If you are developing a strain sensor, so a strain sensor is a sensor that can detect the applied strain on that particular sensor. So applied strain means it will experience some strain, so it will get stretched in certain direction. In that case, if your material itself is not flexible and stretchable, the active material cannot act properly for strain detection. So in those cases, you need flexible and stretchable materials, and you may also need soft materials in certain cases. So there are different examples again given over here. For example, polyamide, PDMS, Ecoflex, PVC, these are flexible materials. And then if you need some conducting polymers, then again you have to check different polymer composites so that you can make a polymer composite with PDMS. For example, you can synthesis nanoparticles, metal nanoparticles, and make a composite with PDMS. Then you will get a kind of bendable or stretchable conducting active material. If you need semiconducting, make that composite with a semiconducting material. For example, any metal oxide, say TiO2, ZnO. There are different processes already reported in literature for all those synthesis processes. You may also come up with your own synthesis process. So here I am again not discussing all this synthesis process. I am just giving you an example so that you get an idea what kind of materials we need and why we need in certain cases. Okay. Then we have soft materials like again PDMS and Ecoflex. So some polymers, some other polymers, okay, may also act as a stretchable and soft material. In fact, the softness of a material can also be changed. For example, if you take a PDMS block and if you change the ratio of crosslinker, then you will find that the mechanical property of PDMS is changing. So these are the techniques that will help you to fabricate or to synthesize materials having different flexibility, different stretchability, different softness. Okay. Then again you can choose active material based on chemical properties. For example, if it's a chemical sensor application, if the sensor is for a chemical sensing application, then or gas sensing application, then you may need oxidizing material, reducing material, or some material which is specific to a certain reaction. To give you an example, for example, say you want to detect glucose, and to detect glucose you need to take help of a very specific reaction which only happens with glucose. And glucose oxidase, this two material react very specifically. So in that case, if you are detecting glucose, what you can do is you make a sensor and then you functionalize glucose oxidase on that, and then once you introduce glucose on top of it, they will react very specifically. Nothing else will react with glucose oxidase because this reaction is specific. Then this reaction will give you some sort of charge transfer, or it will change the electrical property of this active material. That again you can calibrate with the concentration of glucose, because if you increase the concentration of glucose, the reaction also will increase. So this is kind of in a simple way I am trying to give you an example. So you can also select the active material based on the stimuli. For example, in this case we have taken glucose as a kind of material under consideration that you want to detect. Similarly, starch and amylase both are very reactive and specifically reactive. So if you want to detect say blood amylase, you may create a layer of starch, and then if whatever sample you are putting, if there is any amylase, that will specifically react with starch and then will give you certain sort of electrical output. So that way also you can detect the active material. And again, for some reducing gas sensing, for example say ammonia, NH3, it's a reducing gas. So in that case what you can do is you can take an active material say TiO2, which can be partially reduced in presence of ammonia, because ammonia is reducing. So, if there is an ammonia around this TiO2, it will partially reduce TiO2, and that reduction process will create some charge transfer, or it will change the electrical property of that layer, which can be used for sensing application. So, this is the different consideration. These are the different consideration one may consider while selecting the materials. Then based on dimensions also you can select active material. Active material can be a micro material, it can be a nano material, it can be of different shape. For example, it can be microfiber, it can be nanofiber, it can be nanorod, it can be nanoparticle, it can be nanocube. All these things you decide based on the kind of application you choose. For example, if I want to make a sensor where higher surface area is required, for example, in case of gas sensor, I want the gas to react with most of the material, active material, so that you get a better response. In that case you use nanoparticles. So, because nanoparticle has higher surface to volume ratio, you get a higher surface area for that material. So, these are the consideration that you may consider while choosing a material. Then comes to the electrode material. So, an electrode material can be a metal, usually say these are metal either made of gold, made of silver, made of platinum, or made of aluminum. So, metals can be used for different electrodes, but one thing one has to consider is, for example, if the electrode is made of aluminum, then it may get oxidized if it is kept outside or in an ambient condition. So, in that case it is better you use a gold electrode, they are non-reactive. So, we do not want electrode to react with some other material, but again if you use an aluminum electrode for certain reason, then you can insulate that aluminum so that it does not come in contact with say oxygen or air. Okay. So, that way you can design your sensor with aluminum itself. You may also choose different conductive polymer as a electrode. For example, P.PSS can be chosen as a electrode material. However, in certain cases you will find P.PSS can also be used as an active material based on the conductivity. If the conductivity of the P.PSS sample that you are taking, or the P.PSS material that you are synthesizing, if the conductance is very high, you can use it for electrode as well. You can use P3HT, again it is a very well known polymer, all these are well known polymers. You can use those polymers for electrode materials. There are different literature where people used these polymers as electrode material. Then there are some other materials as well. For example, say ITO, this is very conductive material. So, ITO also can be used for electrode material, indium tin oxide. ITO is indium tin oxide. You can use AgAgCl as a electrode. In case of electrochemical sensing, you will find that AgAgCl is used as one of the electrodes in that type of sensors. Okay. So, there are different electrode materials as well. Then we have different material composites. This is again interesting. So, you may find there are materials where people mix metal with polymer, polymer with polymer, oxide materials with polymer, metal with metal, semiconductor with polymer, oxide with oxide. So, they create different composite materials in order to tune their electrical properties or sometimes mechanical properties. So, if you want material to be more conductive, one way is to introduce metal nanoparticles or metal nanocomposites or metal in certain form into it, so that the conductivity increases. Okay. And then once you need say certain sort of mechanical property that it should be stretchable or something, in that case you use polymer composites. So, it depends again on the sensor that you are fabricating. Okay. So, these composites one can prepare based on the sample based on the sensing that they are targeting. Okay. There are several examples in this regard. For example, if I take a metal polymer composite, say gold PDMS composite, can be one option. Okay, this can be one example. For polymer, you may use say P dot PSS and PDMS both in order to create say a more flexible conductive alternative, okay, for certain application. If it's oxide polymer, you can take TiO2 P dot PSS. Okay, so how to create composites? There are several ways of creating composites. Again, I said that you may get this kind of synthesis procedures in different literatures, because there is no specific synthesis procedure. There are different types of synthesis procedure in order to create these composites. As I have said that say gold PDMS composite creation can be very different from nickel PDMS composite creation. So there are literatures where in many cases you will find that the process is already there. So you have to follow those procedures. One can also develop their own chemistry. So I am not going into the chemistry of developing composites, chemistry of synthesizing polymers in this particular course, because it's a bit out of the scope. Okay, maybe separately we can discuss about that. That is a option. But in many cases you'll find that the processes are already reported. But in this course, it's very important that you know that there are different, in fact I would say infinite possibility of materials that we can use. So in this course I would say that it's essential that you first learn the different types of material that we can consider, and in general speaking there are infinite possibilities of getting different kinds of material composites. Okay, so 3 take home messages from this lecture is there are variety of choice for active materials. So one can use different types of active materials even for a single sensing application. Say for temperature sensing only, one can use say P dot based sensor, one can make carbon based temperature sensor, one can use say oxide based temperature sensor. So it's possible. Okay, so there are multiple options available. Based on your requirement you have to choose one. Then materials are selected based on application and sensing. So it's not like you randomly choose a material. It depends on what is the application that you are targeting, and then based on that you select your material. It also depends what kind of sensing you want. Based on that you choose a material. For example, if you want to make an FET based sensor, you have to choose an semiconducting material, because that is where you will get the FET, the field effect in semiconducting material mostly. So you can't choose an conductor, complete conductor, and then try to make an FET. So these are the considerations that one has to take. Then different materials can be used for same sensing application. As I have said that different materials can be used for say temperature sensing application. So these are the 3 take home messages, and we will in the next lecture we will discuss the multidisciplinary aspect of sensor, which is again important because sensor is not limited to a single discipline. One has to know different information from different disciplines in order to make a sensor, not essentially all the sensors, but in most of the cases. So we'll discuss this in the upcoming lecture. Thank you very much.